Welcome everyone. I'm Tracy Fitzpatrick and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's event, AWS Discovery Day, Machine Learning Basics. And presenting today's topic is Terumi Laskowski. Terumi is an Amazon AAI training consultant and author holding more than 25 years of experience in IT. Her passion for cloud computing developed at a very early age. Being a teenager, she always showed her enthusiasm for understanding the technologies that make computers tick. This deep sense of curiosity on technology led her to achieve all the associate, professional, and specialty certifications and was recognized as an AWS authorized instructor champion. Now, please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Cloud Practice Area. Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com. Today's session is designed to make you familiar with important concepts, terminology, and the phases of an AWS machine learning pipeline using real-world examples. And now I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handouts section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic. Hey Terumi, thank you so much for joining us today.
Welcome everyone. My name is Terumi Laskowski and welcome to AWS Discovery Day. Today's topic is going to be machine learning basics. Okay, and I'm really excited to present to you my material here because so much is happening currently in the field of machine learning, artificial intelligence. I'm sure, if you haven't been living under a rock, you probably heard about ChatGPT and other types of AI services. So this right now, if you're beginning in the artificial intelligence, you're getting into a very exciting world. All right, so today's webinar, we'll be covering 4 things, and we'll have some time for questions and answers. So let's take a look. So today, the first thing we'll talk about is, hey, what is machine learning anyway? Okay, and I'm assuming that most of you here are new or have just started in machine learning. So that's my assumption. The second part is machine learning pipeline is phases, right? So, what is a pipeline? What are these phases? So I'll cover those for you. Then we'll take a 5-minute break between 2 and 3. And then when we return from the 5-minute break, we'll talk about the difference between something called the supervised and unsupervised learnings. Okay. Then following that, we'll talk about reinforcement learning and deep learning, and I'll be open to your questions. Right. If there are no questions or comments, I'm going to get started with the first part. All right, so let's go and take a look. So what is machine learning? Okay. And if you look through let's say Wikipedia or any type of history of AI, you'll see a slew of people who are thought to be credited with coming up with machine learning and artificial intelligence. So the person that I'm going to introduce to you is the person who first said machine learning, right? So like, who coined that term, machine learning, right? Well, here it is, right? So there's a professor named Arthur Samuels back in 1959, right? He is thought to be the person who initially said, hey, machine learning. And what is he? So if you take a look at it, so he is one of the pioneers of computer science, especially in the field of computer gaming and artificial intelligence, right? And he is supposedly said, hey, machine learning in relating to, I believe he was creating a machine that will play tic-tac-toe with him, right? So it started out with a very simple game, but still, right? Now, playing tic-tac-toe, playing chess, playing other types of game is commonplace. But back then, back in 1959, it was not, right? So there he is, right? So particularly, this is related to games, okay? And teaching computers to play a good game of checkers. There we are. It wasn't tic-tac-toe, sorry, it was checkers. Sorry about that. Anyway, that's when it started. But what is the definition of machine learning now? Not way back when in 1959, but how has it evolved? So here is the common definition of what a machine learning is. And I've highlighted some terms and concepts here. And after I go over this page with the machine learning definition, we'll go over some of these terms and discuss what do they mean, okay? So the definition of machine learning is this. It's a branch of artificial intelligence. Okay, so that means there's a bigger field of something called artificial intelligence. And one of the branch of that means there are other branches, but one of the branch is machine learning. Okay, so what is that? It's about allowing computer systems to learn from data, okay? And then also improve upon that learning over time. But what's really important here is that these machine learning entities are not programs per se, right? It's not a traditional program. So it says there, without being explicitly programmed. So we'll talk about what that means a little bit later on. Anyway, it goes on to say this learning process involves development of algorithms. And we'll also talk about what does algorithm mean, okay? That it recognizes patterns, make decisions. Sounds like, artificial person, right? Making decisions based on data. And then of course, eventually to predict outcomes. And that's going to be a pretty important part of machine learning, because what we're looking for from machine learning is for it to create predictions of what the answer might be. Okay, so and we'll go a little deeper into that as well. Anyway, says, look, make decisions and predict outcomes, which are then refined as more data becomes available. Okay. So what's interesting about this, before going into each of the terms, is remember I told you a little bit about ChatGPT. Okay, for those of you that have been playing around with ChatGPT, if you have not, give it a try. It's free, but it's really interesting service. But if you look at ChatGPT, the ChatGPT says, hey, I was trained with all the data in the world, yeah, probably on the internet, until I believe it was September of 2021. Okay, so that means everything that it knows, and it knows a lot, but it stops at September 2021. So it has not been retrained, so that anything coming after September 2021 until 2023, this ChatGPT brain does not know. Right? So that's what it is about that last part. It is that it has to be refined as more data becomes available. That means it has to be retrained. Okay. Anyway, so there's a definition of machine learning. So let's go ahead and hit the first part, which is, hey, what is a branch of artificial intelligence? Like, what other things are there? Okay. So here are some of the branches of AI, artificial intelligence. Okay. And I've highlighted the very first one because that's the one that we're going to be talking about today, which is machine learning. Okay. So this allows computers to learn from data without programming, or explicit programming. So explicit programming is that there's no programmer that has to write programs to work with artificial intelligence or machine learning, but obviously underneath it all, it is a program of type that we are working with. Okay. Anyway, and there are others called deep learning. Now we will be talking about deep learning, but this is good to know that deep learning is a different branch, right, of artificial intelligence. And there is a natural language processing, NLP. So NLP, if you're using ChatGPT, basically you will be using NLP, natural language programming, because you're talking to it like a human being. And we'll also talk about, of course, AWS, and AWS actually has models that you can actually do this too as well. Computer vision, robotics, right? Knowledge representation and reasoning, planning and navigation, speech recognitions, and goes on and on and on, right? So these are all the things that usually people think of when they think of artificial intelligence, and understand that machine learning is one part of that, albeit pretty huge part of it, okay? All right, so then you have to also understand, though, that these branches that we just talked about isn't always working individually in isolated space. Sometimes they're working with each other, right? And so here I have one example, a chatbot. Right? So I'm sure you've come across chatbots. Maybe if you go to a website of some companies, they have a little chatbot so that you can ask questions, and it's the machine learning chatbot that is answering your questions and not the actual humans, right? Well, if you take a look at chatbot, right, you can actually speak to some of these chatbots, right? You could talk to it, and if you talk to it, and if the chatbot understands what you're saying, then at some level, they're taking the sounds and turning that into words, right? So that is actually machine learning and artificial intelligence. Also, when you say something, are you happy? Are you angry? Are you questioning something? Are you uncertain? Right? These are called sentiments, and artificial intelligence is able to try to figure out what your feelings are, right? So these are called sentiment analysis, and that's also usually in chatbot too, okay? And also, once it takes the questions that you ask for, you'll try to find the answers for it. That means it can make sense of what you're saying. That's natural language processing, okay? And then also to think, that is machine learning. Okay. Then on some of these AWS chatbots that you can create, they will come back with the human response. So you'll hear either a written text or you have artificial voice that is reading that text. All that in a chatbot is not just one machine learning, but it takes all the other, like NLP and other branches of AI to make a chatbot. Okay, so oftentimes these technologies are used together. Anyway, so that's basically what that is. But let's go into and say, so we've been talking about like programs and stuff, but well, if a machine learning is maybe not directly writing a program, but underneath it all, if it's a program, then why don't we just forget the machine learning and just write programs? Okay, why can't we just write something in Python? Why can't we just write it in Java or .NET? Okay. Anyway, so let's discuss, because programs have its place and machine learning has its place. They actually solve problems, right? So we have some problems that we want to solve, and sometimes we use programming language, sometimes we use machine learning, right? So let's take a look and see how are they different, and how do we use them differently? Under what type of problems do we use programming, and what type of problems do we use machine learning? Okay, so here we go. So program versus machine learning. Okay, so this is a part of the definition that where it says, hey, machine learning learn from data and improve their performance over time without being explicitly programmed. Remember that phrase? Okay, so that's what I'm referring to here. Okay, and I have two pictures, right? On the top, the box says traditional programming. The one at the bottom says machine learning. Okay, so let's take a look at first traditional program, right? So you write your Python code, what have you. If you are a developer, you know what I'm talking about. So when do you use programs? Well, when you have a problem that you want to solve. And how does programs work? Well, it usually takes data, right? It usually takes data. Then you write rules or you write procedures that will manipulate the data, take the input, and then massage it, and then you get the output, right, which is the answer. Okay, so just a simple example, if you have two numbers that you want to add, you know, the input of data is X and a Y, and what happens inside the traditional program is you add those two X and a Y, and then the output would be Z, right, which is the, you know, additive of those two values. Okay, so that addition is the rule that you write. Okay, so that's basically what a traditional program does. Is you know, programmers write the rules, and then you plug in the data, and the program just follows your instructions, right? Basically follows your program instructions and outputs the data. That's traditional program. So why can't we use that for problems that you may have on, you know, machine learning? Well, let's take a look at machine learning. It works a little bit differently. Okay, so machine learning, and I have in there a model algorithm. Okay, so those are usually what they call it. You know, machine learning, instead of saying program, we say it's a model, it's an algorithm. So we'll come to those definitions a little bit later. But as you can see from the left, you see data coming in, just like you had on the traditional program. But isn't that kind of weird? You have answers coming in. Okay, so if you put answers, okay, and you put data, the machine learning is going to spit out rules. Okay, so what that means then is, so for, you know, X plus Y equals Z, you put in Z, right? And then you put in X and Y, and then machine learning says, oh, it's addition. Okay, so that's what they're trying to do. But if it is as simple as addition, yeah, you might as well not use machine learning, right? Probably just easier to do traditional programming. But machine learning is where those rules are not obvious. Those rules are not simple. Those rules may be complex. Okay, so that's the time when you use machine learning. Now, later on in the slide, I'll give you some examples on the type of problems that machine learning will solve for you. And you'll probably be able to see better and understand better, oh, I see how we cannot write a simple program to do that. Okay, so kind of hold off, and you'll see pretty soon what type of, why we need machine learning rather than traditional program. But let's say, okay then, so you got the rules coming out from machine learning. Well, what do you do next? Well, basically, remember, machine learning is to come with predictions, right? You're looking for something to be predictive. So here, this is what happens, is that now you have this model, right? That thing in the middle, which you trained, right? That is, you came up with a rule, and now those rules are like programs now, okay? Then you put data of the real world, right? So the questions that you really want to ask that you don't know what the answer is for, and then the machine learning is going to apply that rule and come up with the answer. But the answer is not like a, X plus Y equals Z, but it's more like a prediction with the probabilities. They'll say, oh, I think it's with probability of 90% that the answer is going to be blank. Okay, so that's basically what a machine learning is. All right, so one thing you do have to kind of understand is that machine learning, almost all the time, is not going to give you the 100% correct answer. it's going to give you a pretty good prediction. Okay, so that means you have to expect that there will be sometimes wrong answers or wrong predictions, and sometimes proper prediction, right? Because remember, it is prediction, right? It's probabilistic. Okay. So when do you use this kind of stuff, right? Where probabilities are okay? Well, let's see. I have some examples for you here. In fact, I have 4. So let's take a look. Email spam filtering. Okay, email spam filtering, right? And so spams, right? It's really like troublesome, and it causes a lot of problems, right? For security and such. But so you want to stop them before it reaches you. Okay, so maybe as the email servers receive these emails with the spam, you probably want somebody or something going through that email and say, I bet this is a spam, so let's go ahead and put it aside. Oh, and I think this is not a spam, so let's go ahead and send it to whoever. Okay. Now think about that and says, okay, so that's a problem that we need to solve, right? But can you write a program for that? Like, can you write a Python program for that? Can you write a Java program for that? Well, chances are you can, but as soon as you find a new type of spam, you have to rewrite the program, right? So these spams are evolving all the time. So yes, you probably can write programs for it, but you probably have to update it all the time. And it's going to be a pretty complex combination, right, of all kinds of things. If you've seen spams, sometimes they look like real legitimate email, and sometimes they don't, right? So there are different rules you have to apply. So it's very complex issue to find out if this is a spam or not. And also, sometimes people write emails that kind of sound like spam, but it's not, right? So that means it's a prediction. That means sometimes they're right and sometimes they're not. So we're looking for most of the time to be correct. Okay, so there you go. So spam filtering would be it's a typical machine learning problem. Another one is movie recommendation system. Okay, so I have here like Netflix, right? Machine learning will guess what movie or TV show you might like based on the kind of stuff that you already like, or based on maybe your market segment. Are you in your teens? Are you in your 20s? Are you in your 30s? Do you do sports? Where do you live? What language do you speak? All that stuff, right? So that, once again, is a very complex problem that a simple programming language probably will not be able to solve that well. Okay. So movie recommendation systems. Voice recognition. Right? Can you imagine writing a program for voice recognition? Right? There are all different types of voices, all different types of intonations, different languages. That's a highly, highly complex issue. And voice recognition systems, like Siri and Alexa and all that, they're all using machine learning, artificial intelligence to be more correct, to recognize what the person is saying. And are they always right? Well, maybe not, right? They're saying, okay, she didn't pronounce that word well. I'm not sure what that is, but here's my guess. Okay, so most of the time they're right. Okay, and most of the time they're not right, or sometimes they're not right, and it's pretty hilarious, right? When Alexa and Siri and they make mistakes, right? It's pretty funny, I think. Anyway, and the last one is fraud detection. So, for example, something like a credit card fraud. Have you had these cases where you used your credit card, let's say online, and then it was declined for some reason, and then you receive let's say a text from your bank soon afterwards says, hey, I think somebody's trying to use your card and I don't think it's you, please confirm if this is you. So there you go. So that's a fraud detection. And usually I say, oh, no, that was me, please don't decline, it was me. But if there's a certain pattern, right, they'll say, but you were in, let's say, Japan yesterday, now you're in the United States, that's very unusual, that's why we flagged it, right? So, sometimes they're using smart machine learning, sometimes they're not using as smart, right? Maybe they don't have enough data. But fraud detection is another one that's really, really hard to write a program in. Okay, so machine learning is the one that says, okay, give me all the data, right? Give me all the data, and let me try to figure out this pattern of what a fraud looks like, and then let me apply that learning to what she just did, and does it apply or does it not apply, right? So that's basically how fraud detection works, and in general, what machine learning usually works. Okay, so there you go. So that's a program versus machine learning. Just to go back here, right, one more time, you look at the traditional program, you have a very clear-cut rule, and then you put the data in, you get the answer, right? And the 4 types of the problems that the machine learning will tackle just does not fit this model, okay? So we're asking the machine learning to find a pattern, right? Recognize a pattern in the data, and the answer comes from the previously, previous data, so that certain transactions were fraud, for example, and that certain transactions were not fraud. And you pump all that data in, and you allow machine learning to learn the pattern, to find the pattern, and then come out with the rule. Then you apply that rule, and then you put in a brand new data, like brand new credit card spending, and say, okay, here's my prediction. This is fraud, this is not fraud. Okay, I hope that's clear. All right, so now let's go into machine learning services in AWS, right? So AWS has tons of machine learning services. So at this point, I'm going to go to that page, okay, and I'm going to show you around, what AWS has. So give me a moment. I'm going to switch to that screen. Okay, so I hope you are seeing my web browser, okay. And let me go to the link. So hang on here. Let me open that up. Just say machine learning, and there we are. Okay, here is a machine learning on AWS. But if you look at the top, you see all services. So this is like, look at all this stuff. Wow, right? But that's all services. This is all AI services. So it's all services that's AI. Then AWS actually has separate category for machine learning services. Now, if you look at machine learning services, you see that a lot of the things says SageMaker, right? So SageMaker, 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 SageMaker. Oh, what's SageMaker? So we will be going into SageMaker, and SageMaker is AWS's flagship service for machine learning. Now we're going to go more into detail on the individual components of SageMaker in this webinar when we're talking about the pipeline for machine learning. Okay, so kind of hold off on a little bit, but I do want to let me see, kind of show you. For example, let's see here. Let's see. Yeah, you know what? I think we'll just hold off on this because let me see. Yeah, oh yeah, there's SageMaker. Let's go to SageMaker. In general, right? In general, what SageMaker is, right? Says build, train, and deploy machine learning ML models for any use case with fully managed infrastructure tools and workflows. So there you go. So that is the flagship product. It's not just one thing. It has like components galore, right? So we will come back to this. Okay, but anyway, so that's your reference page for you for machine learning services in AWS. All right, so let me get back to my slides. Just a moment. All right, so we're back. Okay, so let's move on to the next section, which is, hey, machine learning pipeline and its phases. And you may be saying, what? What's a pipeline, right? Okay, so here we are. So what is a machine learning pipeline? So if you think about how do we use machine learning? Well, you have to first make a decision to use machine learning, right? Because some of the problems is easier to solve by just writing programs. So you start from the beginning where you have the problem statement, and then, these are kind of problems that we have to solve. Oh, it's a spam filter problem. Okay, so then let's go and choose machine learning, right? So that would be the first end of it. And then the other end is you're looking for prediction to come out from this machine learning effort that you're going to put in, so that you have a pretty good probability that when you plug in an email, it's going to tell you, hey, this has a high probability of being a spam or high probability of being not spam, right? That's what you're looking for. So that's an end-to-end, right? So what the pipeline is, is an end-to-end process of making a machine learning system operational. Operational means it's going to go online and everybody's going to start to use it. Okay. Anyway, so in order to do that, there are several things that you have to do in the order. Okay, so there's like a process to this, right? And that whole process is usually called the pipeline. Okay, so here, generally involves a series of steps allowing data scientists, these are the people who usually use machine learning, by the way, and engineers to follow, build, train, and deploy models. All right, so let's go a little bit more deeply into what are these steps that's involved in machine learning. So here we are. So I've kind of listed here about 8 things, right? 8 processes. Now this may be shorter, longer, depending upon the process that you follow. So this is a generic process. Okay. So steps in machine learning pipeline. I will go over each and every one of these, but let me go ahead and go over these right now. One, data collection, collecting the data. Data pre-processing. So you do have to kind of massage the data, and then you build the model, and then you train the model. So we will talk about the differences between building and training the model. And then once you train the model that it's smart now, you have to say, well, how smart is it? So this is model evaluation. And then you may have to make some adjustments. So that would be model tuning. Then finally, you have something that you can show to the world and you're going to deploy that. And then after you deploy it, you have to make sure that it's working okay, that it's still relevant, right? The knowledge isn't old or defunct, right? So that you have to have a model monitoring and updating. Anyway, so let's go over one by one. And so we'll go over all these 8 steps. And when I first started out with machine learning, some of these things were a little confusing to me. I didn't quite understand too well. So, and I'm thinking that maybe some of you may have, some, issues with perhaps, grasping the concept because it's brand new, right? So I actually have some analogies, right? Okay, so I have cooking analogy that I'm going to be using for this. Here we go. What's that, right? Data collection. Okay. So data collection is, hey, remember the machine learning? You have to plug in the data. Well, you have to get the data, right? So it's a process of gathering the data from all kinds of sources. And I have some sources here for you. Databases, some organization give you API, application programming interface access to some data. Web scraping, right? You go to websites and just, grab all the data on the websites, etc. Okay. And on the left here, I have a website. It's called Kaggle. So Kaggle is a very popular place that a lot of machine learning scientists and engineers go to get some stock data. So some data, there's all kinds of different types of data. So let's actually go over there. So let me go ahead and switch back to my screen one more time. So hang on just a moment. Just a minute. Because Kaggle is pretty interesting. So shall we? Kaggle. There it is. Okay. So this is, especially here, see where it says data sets and models? Well, it sounds like machine learning, right? So we're talking about gathering data. So we'll go to data sets. Okay. And here, you could search for all kinds of data sets. So here, let's see if there's anything. All right, so licensed drivers by state, gender, and age group. So if you're doing anything related to these drivers and combinations, what state, like, I'm in Hawaii, so, what if you want to do some machine learning based on Hawaii or based on Arizona or, pick a state, okay? They'll give you gender and age group breakdown. Isn't that nice? Uber data analysis. So there's like tons of interesting data here. So there's like, I think like free service and not free service, and you could download the data and try to solve a problem using this data set. Obviously, it's best to use your own data set because the problem that you want to solve may not fit this data, right? So but if you don't have your own data set, this would be a great place to at least, to create the model and check to see if it's working okay. Anyway, So let me go ahead and flip back to my presentation. Anyway, if you have not seen Kaggle, check it out, okay? All right, so I'm back, okay? So anyway, so data collection. So if I were to use an analogy for this, right? Remember I told you it was going to be a cooking analogy, okay? So here we are, right? So what does a data collection look like? So it's like going to the marketplace, right? To buy ingredients you need for your recipe. There you go, right? So it just depends on, you know, what are you cooking? You know, is it Japanese? Is it Chinese? Is it American? Whatever, right? You'll need different ingredients, and you may need to go to different places, different marketplaces, the things that you need, veggies, meat, whatever, right? That's what we're talking about, data collection, okay? But you have to have a recipe in mind, obviously. Right? You're not going to go and say, oh, I don't know what I'm going to cook, but let me get something anyway. No, it doesn't work that way, right? So in machine learning, same thing. Data collection is about getting the relevant data, right, for your model. And remember, model is what you're trying to train. Okay? Model is the thing that's going to give you the prediction. Anyway, so depending upon the problem that you're trying to solve, obviously you have to collect different types of data. And you know, in machine learning, more isn't always better, right? So I mean, less is not that great, but a lot more isn't that great either, right? You need to have just the right amount, okay? Anyway, so you need the data to train your model. So there you go. So that is the data collection. All right, so let's move on. So the next step is data pre-processing. So now that you have the data, you have to kind of massage the data, mainly because there's sometimes issues with data that you get, right? So the first thing you do is you have to do this thing called cleaning the data, right? It's like washing the data, right? Well, actually cleaning the data means that, you know, some of the data sets that you get, they're not perfect, right? Some data's missing, so, you know, there's some misspellings and maybe numbers are off and stuff like that. So you have to find these things that are not right and fix them, or get rid of the data that, you know, that's not going to work for you. Okay, so that would be data cleaning. And honestly, this takes a long time, especially if you have like tons of data. And then you have something called feature engineering. That is, you're converting the data that you get, you know, the raw data that you get, and converting it to the format that the machine learning understands. So it just depends upon what type of machine learning algorithm you're going to be using, the type of feature engineering you have to do. But there you go. So that you need to do. That's the pre-processing stuff. And then we usually split the data. So if you have, let's say, you know, 10,000 pieces of data, you usually split it to like 80-20. So 80% you use for training, right, the model, and 20% you use for testing the model, right? So you usually kind of split that. So that's usually what data processing is all about, okay? Now here comes the analogy. So the data pre-processing is like, okay, so now that you got your ingredients, you have to prepare your ingredients for a dish, right? So that means if you got veggies, you probably have to wash them, peel them, cut them, you know, whatever you do, right? And get rid of the stuff that you don't need, get rid of the stuff that's kind of rotten, right? That's basically what you're doing, right? And if you have meat, you have remove the bones, fat. Actually, I like the fat, but anyway, anything else, right? That you don't need, and you cut it into pieces that matches your ingredient recipe. Okay, so there you go, data pre-processing. So I also have it here in machine learning. Pre-processing involves steps like handling missing data, and there's something called outliers. So the outliers are like exceptions, right? So for example, if you have data of, let's say, income for a group of people, and you're trying to find, you know, do a machine learning based on the income level or whatever, right? If, you know, you may have somebody that has zero income. You may have someone that has like $1 billion, right? But then those are like, you know, a couple people on the side and everybody else is in the middle. Well, the people that don't make money and people that make $1 billion is going to pull the data in the wrong way. It's not going to be representational. So you may want to get rid of those two outliers, right? Outliers are things that are like exceptional data, okay? Sometimes you keep them, sometimes you get rid of them. Once again, it depends upon what are you trying to solve, okay? So, but in general though, you do have to look at the data and make sure that the data itself isn't going to throw off your machine learning. All right. So the next part is, all right, so now we're coming into model building and training. Right, okay, so now that you have the data, you pre-processed it. Model building is selecting a appropriate machine learning algorithm and developing a model. So I'll go a little bit more in detail of this, but just kind of keep it the way it is right now. Then after you've selected the model, okay, then you train the model, right? So training the chosen model on a data set. Remember the data that you prepared, right? This actually takes place where you take the model and you plug in the data as an input and let it learn, okay? And then adjust the, do whatever it does internally so that it comes out with the trained model, okay? All right, so once again, let's go and take a look. The analogy here is this, right? So model building and model training. So let's take a look. Model building. I have here, it's like, choosing the right recipe for what you want to cook. Okay. And you cook at all the available recipes. So recipes are the algorithm, and pick one that suit your needs, right? Okay. So that means in machine learning, there are tons of algorithms, and you have to pick the one that is going to help you solve the problem. So once again, going back to the recipe, it's going to tell you what ingredients you need. So if you're looking at the model, it says, okay, so my model requires these values, parameters, but it's not going to tell you exactly how much you need, okay? Because you have to kind of adjust, how much you have to have, like how much salt you have to have, how much pepper you have to have, how much of whatever you have to have, will depend upon the situation, right? But it gives you a general makeup of your recipe. So that's the model building, selecting the appropriate model, okay, appropriate recipe, right, for what it is that you want to create. Then you have the model training. So the model training is like adjusting the recipe, right, based on the taste test, right? So that means you've chosen the recipe, now you're ready to cook the dish, right? Try it out. If it doesn't taste good, you make adjustments, okay, until it tastes good. Okay? So the same thing with machine learning, right? So if you come up with something and you say, okay, let's plug in this, spam filter thing. I'm going to give a sample email in there, which is spam, and then your model predicts that, oh, this is fine. This is not a spam. It says, oh, wait a minute. Yeah, it's not working too well because I put in a spam in there and you came out with non-spam. Okay, we need to make some adjustments here, okay? So you try it out. If the predictions are off, then you adjust, right? Whatever the parameters it is that you need for that algorithm so that you get the type of expected predictions that you get. Now, you shouldn't request 100% correct, okay? After all, it is a prediction, right? So, but it's natural to kind of expect somewhere around 90%, or above correct predictions, hopefully, from your models. Anyway, so that's the difference between model building and model training, okay? So the next part is the model evaluation and model tuning, right? So here, model evaluation means, okay, it kind of sounds, it's I think it's pretty normal to say, okay, so let's check and see if this is acceptable, right? So you're assessing, the trained model using different types of metric. So for machine learning, there's something called accuracy, precision. I mean, these are all technical metrics, but those are the commonly used ones. Say, hey, how accurate is my model, right? Oh, it's 95% accurate, okay? Is that good enough, right? Well, that depends on why are you creating this model in the first place? Like who's paying for it, right? Usually businesses are going to be paying for the effort to create the model. So if the business says, yeah, if it's 95% correct, that's good enough for me, then great. If your model comes up with 95% prediction, that's great. You are good to go. But if the business is saying, no, it has to be 97%, but your output is 95%, now you kind of, there's a gap, right? So you have to kind of work a little bit harder to increase the accuracy or precision or whatever you're using for metrics. Then, in that case, what do? Well, one thing that you can do is something called model tuning. So model tuning is you are making adjustments to the model's parameters Sorry about the parentheses. That's my typo. Parameters to optimize the performance, right? And sometimes they're called hyperparameters. I think the hyperparameters actually belongs in that little inside that little parenthesis. Apologies. Anyway, so model evaluation and model tuning. So let's go ahead and take a look at my analogy, right? So here we go. Model evaluation. Now that you have this dish, right? It's like having a taste session, right? Or tasting session. It's not the chef that's going to taste it, right? It's going to be everybody else other than the chef who's going to, eat the food and say, oh, this is good. I think it could be improved a little bit, right? So there you go. You follow the recipe algorithm, tweak the ingredients, parameters, right? Through taste testing, training, okay? And now you want to know how well the dish turned out, okay? That's the testing data, okay? And you get the feedback. In case of the food, they'll tell you yay or nay. If it's machine learning, you'll see the performance metric, okay? So this feedback tells you whether your dish, the model, right, will likely be received by other people and that they'll be satisfied with it. So there you go. And then model tuning is like refining the dish, right, based on the feedback that you receive. So, hey, maybe your friends say, this could use a little bit more salt. If you're looking for machine learning, it says, hey, maybe this parameter needs a little bit of adjusting, or that, cooking time should be reduced, changing the hyperparameters. So these are different types of parameters that you can adjust in your machine learning model. Anyway, so that's how you tune it, okay? And the last two steps are the model deployments and model monitoring and updating. So let's take a look. Model deployment is, hey, now I have a model that's been trained, it's been tested, and we looked at the performance, it's good to go. So let's make this available to the world, right? Let's let our users go at it, okay? So making the trained model available for use in production. That's basically what a model deployment is, right? With the network, or the servers, and all that, okay? Then, after it's running though, you have to kind of keep an eye on it and make sure that the performance that you're looking for is still there. And over time, the accuracy may actually, degrade. And main reason why machine learning accuracy or precision or whatever metric that you're looking for may degrade is because, remember, the machine learning model is based on the data that you plugged in, but the data is the data of the past, right? And some things change over time, right? So if the new world doesn't fit the old data, then the model that you created using old data obviously is not going to serve the new world, right? Okay, so, but you just don't quite know when that is going to happen. So you have to kind of keep an eye, and you have to say, okay, if the models start to, kind of degrade, where the accuracy is becoming like, let's say, below 90%, that's the time I think we have to kind of take a look at the model again and maybe collect the brand new set of data and retrain this model. There you go. So the analogy here will be this: model deployment. So this is the moment you start serving your dish, right, at your restaurant. So everybody's eating it. So there you go. Okay, so that's the model deployment. So the model monitoring and updating is just like keeping an eye on the customer's feedback and review about your dish. Model monitoring is you're keeping track of your model's performance, right, as I say, okay? And you look out for any decline in performance indicators and decide whether the model is still good to use or not too good to use. There you go. So those are all the typical pipeline items. So I just want to go back to that slide that I had. So here we go, right? So this is what we just discussed, is the steps in machine learning pipeline: data collection, data pre-processing, building, training the model, evaluating, tuning the model, and then finally deploying and monitoring and updating the model. Okay, so that's the pipeline. All right, so now let's go back into SageMaker, right? So because I want to show you in SageMaker how the services that are offered in SageMaker in Amazon, it kind of fits this these requirements that you have for the model pipeline. Okay, so when you go to it, this is a page that I kind of showed you, but now I'm going to show you SageMaker inside AWS environment. Right? So let me go ahead and do that right now. So here we go. I'm going to switch the screen once again. All right, so I hope you're seeing my web browser now. And I've already logged into my AWS account. So let's see. I think I did. Maybe not. Let's see. I think I did. Yeah, here we are. Okay, so this is my AWS account. Okay, I've logged in, right? And I went to SageMaker. There we are. Okay. And once again, now I hope you're a little bit familiar with the term now based on the pipeline, right? Building the model, training the model, deploying the model, right? Okay, and SageMaker is managed solutions. So managed solution means that you don't have to worry about the network, you don't have to worry about the servers, you don't have to worry about all that, you know, what we usually typically call infrastructure. All you have to worry about is, you know, solving the problem, okay? Creating your model, that's it, okay? And the easy way is to take a look at here, okay? So here we are. So it says typical SageMaker workflow. And basically, it starts from collecting the data, okay? And in fact, it's not actually, it's kind of, the name is not, you know, not what we talked about. So labeling the data is this. So I don't want to go too deeply in here at this moment because we still haven't talked about the type of learning, right? But this has everything to do with collecting and preparing the data, okay? In fact, if you look to the left here, right? So let me go ahead and open up here. See where it says ground truth? The ground truth is about collecting the data and preparing the data. And notebook is where we actually do the work of training the model, building the model, and let's see, we have processing here, processing those jobs, that is creating the model. And then we have training the model, right? We have algorithms that you can choose. Remember the recipes that you choose, right? Training the model. And then after the model is created, it's called inference. So model, right? You create the model. Then you actually deploy the model. In fact, I think it's in the, here. In the inference, you have this thing called the endpoint. So this is when you have deployed the model to the world, okay? And there are others here that's not in this menu, but it's where you monitor the model and you update the model. So there are other features there. So it's every single step in that machine learning pipeline you can actually do inside SageMaker. But what's nice about AWS is this. You know, some people have already used other tools for machine learning. And they say, oh yeah, you know, I like AWS for deploying my model, but you know, I like to use my own tools for the model. So I don't need some of these, but I want to use some other pieces. And AWS says, look, that's okay. You don't have to use everything in SageMaker. You could use pieces of it if you like. You could just use it in combination if you like, okay? So with SageMaker, you could build a model, you could train the model, you could tune the model, you could deploy the model, right? You could do all those things. In fact, like I said, every single step in the pipeline. So there you have it, okay? So everything that we talked about is supported in AWS, right? And there's actually a course on AWS. It's a one-day course that actually walk you through the entire process from end to end, from collection of data all the way to creating the prediction and also monitoring. So it's a pretty nice class. It's a pretty quick, you know, fast-moving class, but it does hit every single item in the pipeline. So, you know, if you have the opportunity, that may be a nice class for you to take. All right, now let's get back into the slide presentation. Let's see here. Okay, hang on. So we looked at this. Oh, by the way, I have a link here for Amazon SageMaker's built-in algorithms. So this is, remember we talked about, you know, how algorithms in machine learning is like the recipes that you need to cook the food, right? And SageMaker actually has a lot of built-in algorithms already in place. So you don't have to go get it from someplace else. But if you have an algorithm, let's say something like a recipe of your own, then you could actually bring it into SageMaker as well. So it's a pretty straightforward process of bringing it into SageMaker. So whether you use the built-in algorithms, which there are plenty, or bring in the one that you have, SageMaker is pretty open to integrating with those external tools that you have. All right, so I think at this point, let's go ahead and take a 5-minute break. And after 5 minutes, we will cover the rest of the topics. Thank you.
Sure, we are now going to take a 5-minute break, but before we do that, we are going to launch a quick poll that we want to invite you to participate in. Doing so helps us know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register.
All right, welcome back, everyone. So now let us go ahead and go into the third topic, which is difference between supervised and unsupervised learning. This is something that you may hear when you go into machine learning. Hey, you know, what algorithm are we going to use? You know, and you need to be able to understand what these two things are so that you could choose the proper tools that you need to solve the problem. Okay, so let's go and take a look. First, the supervised and unsupervised learning is basically how do you teach a machine, right? Remember, this is machine learning, so you have to teach the machine something. Well, how do you do that, right? So these are the two major categories of how, right, of approaches to teaching a machine. So supervised learning is like going to school. This is where you have a teacher, okay, that has the answers, and it's going to ask the student, machine learning, hey, here's the data, here's a pattern, what do you think the answer is? Okay, and if the machine learning says A, and the teacher says, yeah, you're right, that's A. Or if the machine learning says B and says, no, that's not right, the answer is A, right? So the learning is where you have someone who already knows the answer and is teaching the student, right? So it's like going to school, okay? So there I have like here, it says it's a method where the algorithm learns from the labeled training data. So that's a term that we've been kind of seeing, this thing called label. I haven't really explained that, so let me explain it now. Labels are the data that's attached to the bigger set of data that you're reading in, which represents answers, okay, answers, right? So for example, I don't have it on the slide here, but for example, if you have to solve a problem where you put in a bunch of images of dogs and cats, okay, and then the machine learning have to predict, is this a dog or is this not a dog, right? So in that case, the data that it's going to learn from is a bunch of pictures of dogs and, let's say, cats, okay, or dogs or not dogs, okay, and those data has an answer already attached to it. So the dog picture is going to have a label called a dog, and cat pictures are going to have the label. Okay. Now you don't show that label to the machine learning, but you know that those are the right answers. So after the machine learning learns, tries to come out with a prediction, right, and says, oh, you give them this answer. Is this a dog? Let's say you give them a dog picture, and you know that it's a dog because it's labeled as a dog. But if the machine learning says, oh, I think it's a cat, it says, oh, nope, sorry, you got that wrong, right? So that's basically what that is that, you know, just like teachers already know the answer to whatever they're teaching to the students, and the students have to figure out on their own, but when they come out with the answer, the teacher's there to say, yep, you're correct or you're not correct, okay? Then of course, what good is that? Well, these students go out in the world, and from what they learn, they'll apply that knowledge to the real world. And same thing happens with machine learning. So once you teach them what's right or wrong, they go out into the world, production, right? And then they see the real data, you know, plug in real spam data, and then they'll apply the learning. You know, it's spam or not a spam, right? So that's basically how that works. So that's the supervised learning. So it's something with answers already labeled in, okay? So then that kind of sort of makes sense, and the opposite then is unsupervised learning. So the unsupervised learning is where the algorithm, remember the recipe, right, is given unlabeled data. So it's given data doesn't have any answers attached to it. And the answers they have to figure out on their own. And you may say, what? How does that work? Okay, so let's take an analogy one more time, okay? So it's like learning without a teacher. So how do you learn without a teacher? Like, how do you know something is right or how do you know something's wrong? Okay, so I have it on the last part there. It says it's like being dropped in a foreign country without knowing the language, okay, and having to make sense of your surroundings or your world, right? So have you ever been in that situation where you've been to a foreign country where you're not proficient in the language of that country, but you have to kind of, you know, eat, right, and find a cab or find your hotel? How do you do that? Okay, and you may mimic other people. Maybe these days you probably use an app, but you know, let's put that aside. normally what we do is we kind of observe what's happening around us, and we try to learn the patterns, right? That the surrounding data gives us. That's basically what an unsupervised learning is. So it's partly hit or miss, but eventually, hopefully, with a lot of trials and misses, that you're going to find a pattern that you can apply. Okay, so that's without a teacher, and of course, supervised learning is with the teacher. Okay, so that's the same thing applies to machine learning. So the question then is, well, which one do you use, right? So the supervised learning, you use it when you have a clear idea of what the output should look like. So the great example, once again, is dog or cat pictures. You know what a dog looks like, you know what a cat looks like, it's pretty clear, okay? So in that kind of situation, you would use a supervised learning. How about unsupervised learning? So you use it when you don't have a specific goal in mind, but want to discover patterns. It says, I don't know what it is right now. I don't know the rule. So I want the machine learning from the data to figure out the pattern. Okay. So here, it usually involves unlabeled data. That is the data that you feed into machine learning, doesn't have answers attached to it. Okay. So for example, I have here is customer segmentation in a market data set. So customer segmentation is usually this type. It says, okay, when we talk about customer segmentation in a market, such as if you're selling something, you're usually producing a product that is meant for certain groups of people. So that would be the segmentation. So the question is, well, what kind of segmentation do we have? And what, this product that I have in front of me, what should I target? Okay, and such. So that's usually something you don't have answers for. Just because you pick one person and says, oh, what segment does this person belong to? Well, it depends, right? It depends on the product that you're trying to sell. So there's a lot of unknowns there. So you're looking to depend upon the machine learning to kind of see the pattern that you, the human, do not see right away. Okay. So there you go. So that's a supervised learning, unsupervised learning. Okay. That's just general category. So now let's talk about this thing called the algorithm. Now, algorithm is a term that I've been using once again, but I really haven't really explained it too well, okay? Not yet. But algorithm is the second equation, right? So, or complex equation that you use. That's usually what an algorithm is. So for supervised learning, the algorithm for supervised learning, okay, are trained using labeled data. So we've already talked about that, right? That is, each example in the training data set is associated with the correct output. That is, there is an answer, correct answer attached to it. Okay. Now, some of the algorithms here, and it's okay if you've never heard about it. Once you start, getting into machine learning, you're going to come across these algorithms. The very popular ones are something called linear regression algorithm, logistic regression algorithm, random forest algorithm, etc. So there are a number of algorithms that are for supervised learning. So it requires that you have the labeled data set. Okay? And conversely, there are algorithms for unsupervised learning, right? So these algorithms are used when the information is not classified or labeled, right? And you want the algorithm itself to come up with the pattern. So they're used to structure the input data in some kind of order, find some kind of pattern, right? And some popular algorithm here is k-means clustering, and there's something called PCA, and there are others, right? So that's how algorithms kind of split up. That means you have to kind of understand then, which one am I going to use? Is it going to be supervised learning or is it going to be unsupervised learning? Then I have to choose which algorithm I'm going to be using for machine learning. There you go. So now let me give you real life examples of supervised learning and also unsupervised learning too. So for the supervised learning, I gave you spam detection. So I think I'm not going to go into detail here because I've already kind of explained it. Okay. There's another one, credit scoring, right? So we have these credit scores. Okay. So how do people give you your credit score? Well, it depends upon your past spendings and the credit and all that, right? So banks use them. Banks usually use supervised learning to predict. Let's say if you're asking for a loan, they're going to see, okay, let's see your credit worthiness. Okay, so that would be the credit scoring. So they actually use machine learning from the past data that may or may not fit the kind of spending and the credit, worthiness that you have, and say, okay, this person kind of, we're going to do the prediction here, right? What is the credit worthiness based on this person's data and also the data that we use to train it. Okay, so there you go. So the algorithm is trained on historical data when the input was, with various characteristics and past behaviors and the customers, and the output is whether they, defaulted on their loan or not. And if not, they either give you the loan or they don't give you the loan, right? Okay, so that they usually use a supervised learning on that one. And here's the medical diagnosis. So with medical diagnosis, sometimes supervised learning can be used, right, to predict whether a patient has a specific disease based on the symptoms or the test results, right? So, you have the past data, say this person, the past data, this person with these scores actually had this kind of, disease or this kind of symptoms, right? So you have data with answers already attached to it from the past, and then the model was trained based on that. So now you give this new patient's data, and they'll say, hey, yeah, this person has this type of issue or doesn't have an issue. So there you go. So these are 3 real-life examples of supervised learning. Okay, and you may be as curious to say, okay, so how about the unsupervised learning? Well, here we go. So real-life examples of unsupervised learning, right? Market segmentation is something that I already covered, so I'm just going to not cover that, but it's in the presentation, so please go back and take a look at it. Next one is detecting anomalies. So anomalies is something that is off, right? So off the normal, okay? So unsupervised learning can be used to detect anomalies. So remember, anomalies are some pattern of behavior that is abnormal, okay? So that's like, but what do you consider abnormal? Well, you don't know exactly, right? That's why you use unsupervised learning, so that it understands what normal is, and then it will understand what abnormal is, right? So that's why it's usually used for detecting anomalies. Another one is recommendation system. So some recommendation system does use unsupervised learning. So, if you, and I'm not saying that Amazon uses this, but if you go to places like Amazon and other online shops, if you buy something, you get this thing on the side that says, oh, someone who bought this kind of stuff also liked these things, right? Maybe you would like to have these things. That recommendation sometimes is using unsupervised learning, okay? It really does depend, but I'm talking about the typical cases here. So there you go. So those are the differences and the use cases for supervised and unsupervised learning. Now let's take a look and see SageMaker. So how does SageMaker help you with this? Well, SageMaker actually helps you with both. So it doesn't matter whether you want to use supervised or unsupervised learning. It's up to you as to choose the learning methodology. And then once you choose the learning, you choose the algorithm. And those things are there for you. So ground truth, I've kind of touched on it. It's basically you're collecting the data and preparing the data. And specifically, ground truth is where you take the data and then you label the data. Remember the labeling, right? So if you have, like, let's say, I don't know, 100,000 pieces of data, and you haven't had the time to go in each of the cats and dog pictures and label them cats, dogs, right? So, okay, I need to go through that and go 100,000, images, but I don't have the time. So what am I going to do? Because I want to do supervised learning with label data, but I have the data, but I don't have the labels, okay? Well, you can outsource it. And basically what ground truth does, one service within ground truth is that you can actually outsource your data labeling, right? So you send it off to somebody, and let's say, I'm working in this ground truth online, and I get a bunch of images, and I said, okay, that's a cat, okay, that's a cat, that's a dog, that's a cat, that's a dog, right? So I label it, and then I ship it back to you. So now you have data that's labeled that you can use for supervised learning. And there you go, okay? Another one is called SageMaker Data Wrangler. So this helps the data pre-processing stage that you have to do. Either you're doing supervised or unsupervised learning, it doesn't matter. The data has to be clean, data have to be transformed, all those things has to happen. So Data Wrangler is a nice service to have. Another one is SageMaker Autopilot. So this tool actually automatically creates a machine learning model, right? Which can be both supervised or unsupervised. So there you go. Okay. And then last but not least, SageMaker experiments. So you're kind of practicing, you may not hit the proper algorithm right away. So, you may want to try different algorithms and stuff and see which one gives you the better prediction. So there you go, you're experimenting. Iteration. You can use this for supervised or unsupervised model. It really doesn't matter. So there you go. SageMaker, you can use both of them. Okay, so I hope that was clear. But if you have questions, please ask me during the Q&A session. And let's take a look at the last topic, which is reinforcement learning and deep learning. This one is really close, dear and close to my heart. I like reinforcement learning, but so let's go into that. Okay, so here we go. So what is reinforcement learning? Well, reinforcement learning is actually, it's a third category of the type of learning. So it's actually supervised learning, unsupervised learning, and reinforcement learning. You see, so those are the three different categories of learning. But the reason why the supervised and unsupervised was kind of separated, because those are the very common ones. And at times, though, you may do reinforcement learning. Okay, so what is reinforcement learning? Well, so let me give you an example of this. So I train dogs on the side. Okay, so it's my hobby. And dogs learn by reinforcement learning. That is, if you're teaching a dog to sit, right? You say sit, okay, and they don't understand because they don't speak the language, right? But if they accidentally sit down for some reason, you give them a treat that says, oh, that's a reinforcement, okay? And if they don't sit, you don't give them anything, or you may give them punishment, probably not. But reinforcement learning is if you do something right, you get rewarded for it, and if you don't do something right, you either don't get rewarded or you get a negative reinforcement. That is, you get an opposite of that, right? So just like training dogs, right? And humans to a degree, we work for rewards and we try to avoid punishment, right? So that's also reinforcement learning. So there you go. It's an approach, right, of training. And AWS actually has a real interesting service. It's a service, but it's like a game that people can partake. It's called Deep Racer. Okay, so let me show you what Deep Racer is. I mean, show you the service, right? So hang on, let me go ahead and switch to this. And this is an example of reinforcement learning. Hang on, let me get the screen for you. Here we go. So this is called Deep Racer. And so Deep Racer is, I'm not sure if you could tell, but it's a car. Okay, it's like a model car, right? And with the Deep Racer, what you do is there is a racetrack simulator. So it's like a track that you race your model cars in. Okay, then you get your car, right? Okay, and it's a machine learning trained car, right? It's almost like Tesla, right? Okay, and then you teach the car to drive safely on the track, right? And the tracks can be like all kinds of different tracks, right? It could look like a figure 8. It could look like a big O. It could look like all kinds of mixtures of complex turns and straight lines and things. So the car is going to learn how to drive on that track, and the way it learns is it'll initially go straight and probably it'll go off the track, right? Then it gets penalized, right? Okay, I'm not sure what the penalty is, but I think it's like minus points or something. So if the second time around they go and they try to stay inside the track, then they get rewarded. Right. If they stay inside the track, they get rewarded. If they go outside the track, they get penalized. So you have to actually, this card is going to try this over and over and over and over and over again. And after you do how many hundreds of trials, the car is eventually going to learn how to negotiate this track, right? It's pretty interesting. And it's not as simple as that either, because you see, if you train on one pattern, so let's say in this case here, you have this like a track that looks like a shoe, right? Okay, so if you train on that, the car may be like perfect on that. But what if you put it on a totally different track with different curves? You know, how would it do, right? Chances are, it's not going to do well on figure eights and stuff. So remember I told you that machine learning is about prediction? And we're not looking for perfection, but we're looking for something called generalization. So generalization is a learning that you can apply to a lot of places, right? So you want to train the car using reinforcement learning to generalize so that no matter what type of track that you put this car in, that it can negotiate that track, right? And what's really neat here is that this is all simulation. You could do this all inside your AWS account, but you can actually buy a physical model, and I think these people meet in physical places like Las Vegas, I guess. I'm not sure. I've never been to one of those, but I have met people who actually bought these cars. Now, once you train the car inside AWS, you can move that model inside the actual physical model car, and you can race your car with other people's model cars in the actual track, right? Sounds pretty exciting. And let's see if they actually have pictures. Yeah, see, here we go, right? So here's the simulation, okay? And here's the, like this person is, taking that track that kind of looks like all kinds of little curves and stuff. And then, they're training the actual car. And then people get together and they actually run the actual model. And let me see if I could find the model. See, there it is right there, right? See, here's the model, right? So this is the actual physical model that you can buy. I'm not sure how much it costs, like 150 bucks or probably more. I'm not exactly sure. And there you have it. Okay, it's pretty neat idea, don't you think? So what does it do? Can you use this for something? Well, probably not, other than just just racing. But it's a good example of a reinforcement learning. Okay, so let's go back to that, to the slides. Hang on here just a moment. All right, so that's Deep Racer. Okay, kind of showed you the screen already, the Deep Racer, so check it out. Now, the next topic is deep learning. Right? So, okay, so if reinforcement learning is like a supervised learning, like unsupervised learning, then what is deep learning? Well, deep learning is a little bit different. It's not a separate category of teaching, right, or learning. It's a type of model. It's a type of model, so that's a type of algorithm, okay? So it's a type of model that can be applied in supervised, unsupervised, and reinforcement learning settings. Oh, okay. So deep learning is something that you can use on any type of learning that you may have, okay? So, but what does it refer to? It's a special type of model. It's a special type of equation, if you want to think of it that way, right? Okay, but that model looks like human brain, right? So it says deep neural network. That means neural network is something that mimics the human neural networks. Okay, so deep learning model can be trained on labeled data, classification, regression, unlabeled data, or environment where they receive rewards and punishment. So you can use it on anything. But remember, on each of these categories of learning, you have to choose an algorithm. So in this case, if you wanted to, you could choose a deep learning models. Okay, but what is that exactly? Like, what is the difference between traditional models compared to deep learning models, right? What's the difference? So the traditional model is like, it's like a child learning from the picture book. That's what I have here. That means child looks at the animals and says, okay, I see big ears, nose, tail, that's a dog, right? I see small ears, furry nose, whatever, that's a cat, okay? So that's basically what a traditional ML is like, but the deep learning is like, it's like an adult, right? It's an adult learning, right? So adult sees many animals in many contexts, right? From many sides, from top down, side, bottom up, whatever, right? So they've seen it all, okay? So they can recognize all different types of animals, right? Whether they're drawn pictures, scribble, doodles, whatever, right? So that means we as an adults can apply our learning, and we're more flexible. So it says it's more abstract, so that we can understand abstract concepts, right? Does that kind of all make sense? Because deep learning, if it's going to mimic our brain, right, it's recreating our neurons, and neurons supposedly is how we make associations, and we learn. That's how we learn. So that's how computer learns. So it's an artificial neural network. Okay, so that is what deep learning. And that's how it's different from traditional ML, because traditional ML does not use artificial neural networks. It simply uses, and I'm not saying they're simple, but it's different because it's more like a, equation per se. Okay. So deep learning and neural networks, then how does that relate? Okay. Deep learning is oftentimes associated with neural networks, right? Because it uses artificial neural networks called deep neural networks for learning the process. So without reading this whole thing, right? So if you look at the picture on the left, you have data coming in from the left and the answer coming out on the right, okay? So that's basically what it is. But in between, you have these layers, okay, of neurons. And neurons connect with other neurons, and some of the connections are more stronger than the other. And that's basically how supposedly our brain works too, is that when we learn something, certain associations between neurons, the connection becomes thicker, right? And some connections break or they become thinner. And whatever you strengthen is the learning path that we're going to take. And that's basically what our learning is. And that's what happens in the deep learning neural networks too. So, and you have here the input layer, the output layer, and then you have this thing called the hidden layer. And the deep neural network has many, many layers of hidden layers. So this one's only showing you 2, but you could have 3, 5, 10, 20, how many ever are you talking about, okay? The deeper you have, the more complex the learning, right? So more smarter it is, I guess, right? Or more abstract learning that you can have. Basically, that's where the neural networks come from, okay? So what is the real life example of deep learning then? Like, when do you use that? Okay. So I have some examples for you. Image and video recognition. The cat dog thing, right? Is this a cat? Is this a dog? That actually uses deep learning. Because you see, even when you see a picture of a dog, right? You have the picture of the dog, maybe from straight forward, maybe from the back, maybe from the side, maybe from the angle, right? It's the same dog, but as far as the images are concerned, they're completely different. How do you know that these are all the same dogs? Well, you have to make certain assumptions, right? It says, okay, I've seen these dogs, things called a dog, from all angles. So it really does take something like a deep learning to do. So image and video recognition is basically deep learning. Voice assistant, same thing, right? Alexa, Siri uses deep learning for speech recognition, right? So it's a pretty complex task. Self-driving cars, right? Isn't it amazing these days? You don't actually have to touch the handle to drive cars. That's pretty amazing to me. But look, your environment is different all the time. How does a car make a decision like that? Well, once again, it's deep learning, okay? Self-driving cars. Medical diagnosis. Now, remember, we talked about medical diagnosis using supervised learning, but there are certain types of medical diagnosis where deep learning is used as well, okay? Like tumors or from the MRI scans, which usually helps like doctors in trying to diagnose medical diagnosis. Language translation, same thing. It's not easy, right? We complain about, this translation, this whatever translate doesn't work right. Well, it's hard, right? It's hard. It's hard to mimic a human, right? Because human beings are so flexible. We have so much knowledge. And you basically have a deep learning that's trying to be a human, right, in that stage. So it's hard. So something that is hard, even for human, deep learning is usually applied. Okay. So let's now take a look at some of the AWS deep learning services and products. Okay. So AWS actually has something called the Deep Lens, and the picture that I'm showing you on the left, this is the actual product. You can buy it in Amazon.com if you wanted to. So what is it? It's a camera, okay, that you can download your machine learning models into. So let's say, for example, you wanted this to be a, I don't know, maybe a camera that monitors your house for your pets, maybe, right? And maybe you have 3 pets. I have 3 dogs. They all look different, right? And when I'm away, I may want to say, I wonder what this one of my dogs are doing compared to my other dogs, right? So how do you recognize, how does a camera recognize my 3 dogs? Well, use deep learning, right? So it's integrated with the camera so that you can actually create solutions like that very easily. So it's a piece of hardware that integrates with the SageMaker, and you could put the learned models in here, so you could train the model, place it into this deep lens, and it works, right? Amazon Recognition. So Amazon Recognition is a image recognition from your photos or images. So if you feed it an image, it'll be able to recognize objects like people, text like mountains, skies, activities like volleyball playing, baseball, right? That's pretty smart. But it's already been trained. Okay, and I'm sure it's continually being trained. So you don't have to worry about training this deep learning model. It's already been trained by Amazon, but so they give you access to it. Amazon Lex, right? This is actually for creating chatbots, right? So it does use a natural language understanding, so you could speak to it, you could write to it in English or any other language that it supports, and then it will try to figure out what you're trying to say and help you. Amazon Comprehend. It's a NLP, natural language processing, that uses machine learning to find insight in relationships and text. So what they're saying is, what are you trying to say? Like, what is your meaning here, right? Are you trying to be nice? Are you trying to be mean? Are you angry? Are you satisfied, right? So you can use Amazon Comprehend for that. And Amazon Transcribe uses deep learning to automate speech recognition to convert speech to text. So, if you see subtitles and stuff, you could definitely use Amazon Transcribe. Once again, these models are already trained, and you could just go ahead and use a trained model, right? So there you go. For all these things that we just covered, I just want to make sure that we are able to, let's see if we've actually done what we were supposed to do for this webinar. That is, do you know what machine learning is? Okay, I hope you do, right? And learning pipelines and phases. Even if you don't remember all the 8 phases, you pretty much understand how you collect the data, you pre-process the data, build the data, train the data, right? All that stuff, right? Okay. Reinforcement learning, a difference between supervised and unsupervised learning, right? The learning with teacher and learning without a teacher. You're kind of like, you don't speak German, but you're asked to go to Germany. Like, how do you find the cap, right? So there you go. And reinforcement learning, remember I told you about the dog, right? Give it reward or not give it reward. And then you have deep learning, which often uses deep neural network to mimic the human brain and the human neurons. And you can use it on any other learning style. You could use it on supervised learning, unsupervised learning, and you could use it on reinforcement learning. You can use it on all that. Okay, so that was a lot of information, and I hope that was helpful for you. And now I'm open to any questions that you may have.
Thank you, Terumi. That was very informative. I know everyone is looking forward to the Q&A session, so go ahead and start putting your questions into the questions panel. And now I'd like to give the presentation rights over to Rimi, our vendor manager, to introduce our promotions and webinar-related courses.
Thank you so much. And once again, a very warm welcome to everyone who has joined our today's session. Now, I would like to take you all through some of our handpicked resources, which we think will immensely help in accelerating your learning journey on AWS. Starting off with a quick overview of Netcom Learning and what sets us apart from the other cloud training leaders. We have very recently been recognized by trainingindustry.com as one of the top 20 IT training companies in the US. Another major driver of our expertise is our 25 plus years of industry presence. We have been able to service over these last 25 years to over 80% of the Fortune 500 companies in both the B2B as well as the B2G space. Now, we just wanted to mention that this session is being recorded. So in case you want to refer back to any of the topics that will be covered during the today's session, we will be sharing the recording with you later on, so you can access the recording through that link. Moving to the recommended courses, which we think will best suit your learning journey. What you see right now are some of our upcoming training batches on the top courses, which you can register for. The dates have been mentioned, but in case you have any queries regarding the same, you can at any time reach out to our team. We also have a mix of the most relevant resources, which will help you get a better understanding on some of the other AWS courses. Moving on to the AWS skilling program. So this helps you to develop role-based cloud skills, working side by side our champion level AWS authorized instructors who train cloud professionals on the latest AWS technologies and tools. So now as a part of the program, you and your organization both may also be eligible for free AWS certification exam vouchers and extended lab facilities that extend up to 5 weeks after the completion of the training. Now we are excited to also bring to you the AWS Skill Builder, which is a new learning center with 600 plus free digital courses that is built by the AWS experts. This includes the game-based learning opportunities with CloudQuest and team-based competition with Gen. Its unique set of offerings actually include practical real-world and hands-on lab experiences in a live AWS environment. Now, this is something that we personally love because it showcases the effort that the AWS team takes to make the learning as fun and immersive for the learners. Moving on, another big announcement that we have for our learners today, and something that I had given a hint in the previous, in one of the previous slides, is about our ongoing discount fest, which, as a part of which, you can now choose the AWS training which suits your job role, and you can enroll yourself at almost half of the original price. Please note that this offer is applicable only on the course trainings and not on the course certifications, and the last date to enroll for this is September 30th. Moving on, our free AWS e-learning resources follow a self-paced training model wherein you get the liberty of accessing extensive course-related videos that are delivered by the AWS subject matter experts on the go. So these videos cover the availability on the device of your choice. So you can access them from your laptop, from your tablet, from your phones as well. So please feel free to access these free resources and make the most out of them. Additionally, please feel free to register for a demo to get an idea on what our 2-hour private group trainings on AWS entails. Now, these trainings will be delivered by our AWS authorized instructors with an agenda of understanding the different AWS services and solutions, and will be beneficial for you to devise a roadmap as per your team's current learning needs. The Amazon Web Services Learning Needs Analysis, which we also call as AWS LNA. Now, this is a free self-assessment tool that helps you identify your organization's cloud skills gap. That includes the participating employees to complete an adaptive e-survey that takes no more than 15 minutes, depending on the role. The idea here is to come up with a targeted, cost-effective training and certification plan that's right for your organization and addresses the specific needs of your employees. Moving on, we have the Learning Passport next, which is a flexible team training package specifically designed and customized for the number of learners you have. The Learning Passport is redeemable across our entire portfolio, which covers more than 4,000 official courses valid over 12 months. Now we have an exciting solution for you, which is Netcom Plus Learning Subscription that is there for our enterprise customers. So all you need to do here is to pay one time and you get unlimited access to authorized training from top vendors that includes AWS for a span of 12 months, which is 1 year. Currently, we have 3 packages available. You can get started for free with a silver pack, the one that you see on the first block.
which allows you access to more than 300 learning modules. You can upgrade to the gold pack for just $199 and access 400 plus learning modules in addition to the silver pack benefits. And lastly, we highly recommend our most popular offering of all and ideal for our enterprise customers, which is the platinum package that can be unlocked if you have more than 10 learners. Now, in terms of the benefits, it gives you access to 400 plus learning modules and 100 plus virtual instructor-led courses across top vendors. So it's a great offering that Netcom team has curated just for our learners. So if you require the details, we will be sharing all the details with you, the links with you. Please take some time to go through them. And if you are interested, we have our team uh, that can answer any of your queries that you might have around the learner subscription. Now, in addition to our custom programs, do feel free to also go through some of our additional resources, which are curated, keeping the learners' needs in demand, and let us know learners' needs in mind, and let us know in the comments if you have any recommendations for us with respect to coming up with more such assets. Now, apart from our virtual sessions, you can also catch the relevant updates related to IT and business training through our social media handles. So please feel free to follow us on all for all the latest updates. Now, lastly, the CEO of Netcom Learning is an avid writer, and you can check out a glimpse of his book, which is a practical, actionable guide on how to boost performance, successfully manage change, and innovate more quickly. Thank you.
Thanks so much for guiding us through that information, Remy. And now we're going to go ahead and jump right into our question and answer session. First question we have today is, what are some use cases of using machine learning on AWS?
Right. Well, thank you so much for asking that question. Now, throughout my presentation, I gave you specific real life examples for supervised learning, unsupervised learning, and reinforcement learning, as well as deep learning, right? So any of the things we covered in that are the actual use cases that you can use on AWS, because SageMaker and the supported services actually supports any of those concepts that we talked about. So just to kind of reiterate some of the use cases are, remember we talked about fraud detection, right? So you could do that, like credit card fraud detection, speech recognition, image recognition, text analysis, right? Because we could do sentiment analysis, so you could just kind of feed a text and try to figure out what it means, what is its intent. Chatbots, yeah, that's a good one, right? So Lex will help you create chatbots. And any kind of any kind of analysis that you want to do that you can't really figure out the patterns to. If you're looking for a pattern, and if you want to come up with the prediction given the data, that's basically what machine learning is all about. So yeah, any of those things that we talked about in the webinar and the one that I just mentioned, definitely you can use AWS for.
Next question is, can I integrate third-party machine learning frameworks with AWS?
Oh yeah, definitely, right? As I think I just mentioned that once, but AWS is pretty open to the tools that you've already been using outside of AWS and bring it in or work with AWS SageMaker, any part of it. So SageMaker is a complete solution, but you could take piece by piece and combine them with whatever you have. So because you're asking about the machine learning frameworks, right? So some of the popular framework, one is called TensorFlow, and it's developed by Google. And AWS it's basically TensorFlow is open source, and AWS is compatible with that. Okay, TensorFlow is basically used for creating deep learning models. Okay, so it's compatible with that. Another one is PyTorch. It's a machine learning library for programming language using Python, right? Developed by Facebook, and it's really very flexible and efficient for building complex models. A couple more is MXNet. If you heard about it, it's a deep learning framework. Keras, it's a high-level neural network API running on top of TensorFlow. Scikit-learn, you may have heard about it. Scikit-learn, It's a machine learning library for Python, okay? And also Spark MLlib. So MLlib's Apache Spark machine learning library. So these are 6 very common machine learning framework that AWS is totally compatible with.
And let's take one more question. How should we handle missing or corrupted data in a data set?
Yeah, so this is a great question, right? So this applies to the machine learning pipeline, the data pre-processing step, right? So first, you have to go through the data and figure out which one has missing data, right? So if you're talking about missing or corrupted data, right? So you say, which one, right? So if you have 100,000 pieces of data, how many of them do you have, okay? Now, first thing you can do is if you have plenty of data to work with, you may just want to delete the data, right? Delete the corrupted ones. Says, okay, we got like maybe 100 pieces of data within, 100,000 pieces of data. We could probably safely delete those data. That's an option, right? Or there's something called imputation. So you could try to figure out, rather than deleting the data, you could try to figure out, like fill in the gap. So, okay, maybe we'll take an average, or maybe we'll take a mean if we're talking about like a number. And if it's a category, you may want to use something that's like a very common category, etc. So you're trying to figure out, but of course, you don't know if you're going to be right or not, so you are taking chances. But if you delete the data, you're also taking chances too. So, the data is missing. It's kind of hard. Next one is, there are many others, but one of the things you probably should do is talk to someone who understands the data, right? Because if you say, I think I'm going to delete the data, but the expert who knows about the data says, no, you probably shouldn't be deleting that data because those data is really like meaningful. So you may not get an accurate model if you delete that data. Or if you try to impute the data, that is, if you're trying to figure out what's the value that should go in there, well, maybe that maybe that expert may know the proper value to put in that will work for you. So yeah. There are others. There's something called prediction, there's flagging, but yeah, there are many things you can do. But I think in the end, probably it's good to always consult with the expert who is expert in the field for whatever the data comes from.
Once again, I want to remind you that as you leave this session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.